At the end of the video, there were 4 formulas that I talked about, and the formula that we're going to use to convert the polar angle into a the polar coordinate into a rectangular coordinate is we're going to use x equals and y equals. So on your notes, I said x equals what?
2 cos 4.
No. R cos theta and y equals r sine theta. Okay, so to find our x coordinate, we're going to do -2 times cos of -30 degrees. And to find our y coordinate, we're going to do -2 times sine of -30 degrees. So do you guys want to do -30 degrees? Or do you want to look at the positive angle? 330. Okay, we'll go ahead and use that. Now, if the angle is ever something on the unit circle, then you're going to use the unit circle to simplify it. Does that make sense? If the angle's on the unit circle, you're going to use the unit circle to simplify it. So I'm going to say my x coordinate is -2 times cos of 330 degrees. My y coordinate is -2 times sine of 330 degrees. Okay, so you guys are going to need to look at your unit circle, and you're going to figure out what cos of 330 is and what sine of 330 is. And you can grab one of those desks right there and just pull it right over here and work on it over here. So if we look at our unit circle, cos of 330 is, shouldn't be negative though, right? Because it went to the right? Oh, your final answer should be negative, yes. Sorry, so -2 times, what's just cos of 330? √3/2. And then y equals -2. What is sine of 330? What's sine of 330? -1/2. So when we simplify this, our coordinates are -√3 and +1. And the reason we did that completely by hand is because we recognize that that angle was on the unit circle. Okay? For the next problem, is that angle on the unit circle? It is not. That means we're getting our calculators out. What should my calculator be in? Degrees, because 122 degrees. So I'm going to say x equals 3 cos 122. Y equals 3 sine 122, and I am not doing this problem by hand. I'm getting my calculator out, I'm typing it in. And you have to be careful about this because this assignment is going to switch back and forth between radians and degrees, and you have to make sure that you're switching your calculator each time. So this particular problem happens to be in degrees, so I'm going to switch my calculator into degrees, and I have 3 cos of 122. -1.590. Yeah, that's fine. And then 3 sine 122 is 2.544. So if it's not an angle that's on the unit circle, then we need to type it in our calculator. Okay? How do we feel about those? Reasonable? Yeah? Okay. So we're going to work on these for a couple minutes, and then I'm going to show you the ones on the back page. All right. So go ahead and flip it over. We had 2 other formulas that were to help you convert into polar form, and that was that r squared equals x squared plus y squared. Or if we wanted to think of the r as being completely isolated, then we could say that r was the square root of x squared plus y squared. And the other formula was tan theta equals y divided by x. Or if we want to think of the theta being alone, then we would say theta equals tan inverse of y over x. And put a star right here. The theta is the tricky one because the angle can be like the angle the calculator gives you could be wrong depending on what quadrant your answer is supposed to be in. So if you're using your unit circle to answer the problem, then you just have to make sure, oh, that point's in quadrant 2, so I choose the angle in quadrant 2. But if you're using your calculator will only ever give you an answer in quadrant 1 and 4. That is the only way your calculator ever gives you answers. So we have to remember that if our answer should be in quadrant 2 or 3, that if it's in radians, we might have to add or subtract pi, or if it's in degrees, we might have to add or subtract 150, or 180, sorry, 180, not 150, okay? So I'm going to write a note to myself here. If quadrant 2 or quadrant 3, we might have to add or subtract pi, or we might have to add or subtract 180 degrees. So for this side of the page, it is really important to know what quadrant your point is in, because it makes a big difference with which angle you put as your final answer. Okay? So the quadrant matters. So this first problem goes to the right, well, it's 0, but it goes to the right and up. So what quadrant would that be? First quadrant. This one goes to the right and down. Quadrant 4. This one goes to the left and up. Quadrant 2. This one goes to the left and down. Quadrant 3. This one goes to the right and down. Quadrant 4. This one goes to the left and up. Quadrant 2. Okay, so do you see how we're thinking about that before we get started with the problem?
Yeah.
Okay, so now we're going to go ahead and use those formulas. I'm going to say to find my r value, I need to take the square root of x squared plus y squared. So I'm going to take the square root of 0 squared plus 1 squared. And what is 0 squared plus 1 squared? That's 1. And the square root of 1 is 1. Okay? Then to find theta, I'm going to say theta is tan inverse of the y-coordinate divided by the x-coordinate. So the y-coordinate divided by the x-coordinate. What is 1 divided by 0? Undefined. So we are thinking, where on the unit circle did we get undefined? Because it really did happen. We had 1 divided by 0 on the unit circle. Pi over 2. So undefined angles happened twice on the unit circle. They happen at pi over 2, which is up, and they happen at 3 pi over 2, which is down. Which one should we use for our quadrant 1 angle? Up. So we're going to say pi over 2. So this point in polar coordinates would be 1 comma pi over 2. All right, let's look at number 13. So for this one, we're going to say r equals square root sign x squared plus y squared. So 36 plus 9 is 45. So we have the square root of 45, and we should simplify the square root if we can. You can, well, it's not a perfect square, but you can simplify it. Yeah, so 45 is 5 times 9, right? And then 9 is 3 times 3. So we have a pair of 3's and a leftover 5, which is why we know it's 3 square root 5. Okay? Now, I've got theta equals tan inverse of 3 divided by negative 6. So I'm doing tan inverse of negative 1/2. Is tan inverse of negative 1/2 something that we find on the unit circle? A y-coordinate divided by an x-coordinate becomes 1/2. Is that on the unit circle?
Yeah.
Not as tan. Right? So if we think about this, 1/2 is on the unit circle as a plain x-coordinate or a plain y-coordinate, but it's never on the unit circle as y divided by x simplifies to be 1/2, right? So this is not a unit circle question. This is a calculator question. Okay? Now, in the instructions, they tell us that they want our angle between 0 and 2 pi. So, should our calculator be in degrees?
Radians.
No, it should be in radians. So, I'm going to switch my calculator into radians. And I'm going to do tan inverse of negative 1/2. And what I told you guys was the calculator always gives us an answer in either quadrant 1 or quadrant 4. We want our answer to be in quadrant 2. So can you tell which quadrant this answer's in? It's a slightly negative radian angle. It's either 1 or 4. It's in quadrant 4. Okay? So remember what I said. Tan inverse is either in quadrant 1 or quadrant 4. If we want this to be in quadrant 2, what do I need to add to this angle? I need to add pi because I'm in radians. I would add 180 if I was in degrees, but since I'm in radians, I add pi. 2.678. So 3 square root 5, comma 2.678. All right.